up in this point has no idea what blockchain technology is? Okay, cool. Then I'll ask at the end of the session whether they got better. First I want to introduce the team. We had a team of interns at Labs in 2015 working on blockchain. Then the solution was, okay, it's way too early, it's little technology, little infrastructure, little tutorials. Now there's a group of 4 really talented students working to see, okay, what can blockchain technology do within the digital marketing industry. It's Bas, Bogdan, Edward, and Filippo. And the coaches are Dirk, who's here as well, Ruben, and me. So for now, I'd like to introduce Bas here, who's going to tell a bit about a history of trust. And from there on, we're going to go to blockchain technology, which Filippo will do.
Thanks, guys. Thanks, Bas. So I think that everybody here at this point has heard about blockchain, so they will feel a little bit different. We're going to talk about how we got to this point with the blockchain technology, and we're going to do it with a brief history of trust. And after that, we're going to discuss how that trust translates into a digital age. So going way back in time, and this story starts across the road in Ebla, which is one of the earliest kingdoms in Syria. It was founded about 5,500 years ago. And one of the greatest finds there in the excavation were 2,500 clay tablets that formed together the Ebla library. These gave us insights in their everyday lives, their economy, and for this talk, most importantly, the exchange between kings from different countries, or diplomatic exchanges. So I want to take a step back and think about what an ancient diplomacy is. Even back then, we have different groups of people speaking different languages, living in different kingdoms, having different goals, worshipping different gods, and practicing different religions. And these peoples can be allies or enemies, but they all have to communicate with each other at some point in time. We're now going to look at the diplomatic exchange between 2 kings of 2 different countries, and how they managed to trust each other in that period of time with the limited amount of resources they had. So this is one of the examples. It's the Hamazi-Ebla letter. It's an exchange between the king of Ebla and Hamazi. As you can see in the first part, it says a sender and a receiver part from the one king to the other king. In the second part, it has the actual message. In this case, it's they are going to trade some wagon for some ropes. And in the third part, it's a validation message. In order to be able to communicate, they had some sort of system to trust each other. And the next part is a sentence that had to be structured in a specific way that only the kings knew, which they had validated beforehand, so they could validate that was actually a legitimate message. And the last part was a signature of the king itself. So this message had 3 specific features, and the first was that 3 strict guidelines that are structured way of writing and delivering the messages, which was agreed on when they had met before. It was public. When they were delivering the messages across the country, they were going to every village and announcing the message they were sharing. And it was append only, because it was written on a clay tablet, you could only etch into it and not take away from it. And these 3 very simple features established trust from kingdom to kingdom, even in that long time ago, and even between very large distances. So if we jump ahead in time a bit, in the 15th century, we have the concept of double entry bookkeeping, which sounds in itself very boring, but at that time was actually very revolutionary. The concept behind this was that for every transaction, there should be 2 books. On the left would be debit, and on the right would be credit. If everyone did this correctly, and there were no thieves in the room, it would balance out. It allowed this ability to trust another entity that you don't fully know or inherently trust. So if you go back to these 3 guidelines, or these 3 features, they all had the same. So you had strict guidelines on how to structure the books, and that you had to do it with 2 people. It was public. We still talk in these terms to this day. When companies go public, they open their books and they share what they know with the whole world. And again, it's append only. It's a database of transactions or records that you cannot go back into. There was, however, a flaw with the system. Having double entry bookkeeping at some point beyond a certain amount of people doesn't scale really well. So in 2008, we all know when something very wrong with the Lehman Brothers. The books they shared were very different from the actual books they had. This was at its very root base a failure of trust. A lot of issues here were that there wasn't a great incentive or a great mechanism for proper governance. However, the basic element of 2 books as a way of trusting each other was still there. around the time this happened, alongside the financial crisis, Bitcoin started to become really popular. You could say that people had lost their trust in the financial system and were looking for another system that they could actually trust. So all the blockchain is essentially trying to do is creating a system of trust. So yes, it's a fully decentralized public ledger with all the features it has, but in its root case, it's very simple. It creates trust and it ensures information is permanent. It allows different people that have no access to each other and don't know each other to fully trust each other. So if you go back to these three principles, they have existed for thousands of years and we're just reusing them. It has strict guidelines on how to structure the blocks. Everyone can access the ledger and it's append only. So now we know a bit more about the history of blockchain and about the key principles. We want to share with you how that translates into a digital world. And for that, I'm going to give the word to Filippo.
Yes. So, so now we go for blockchain technology. So as we've heard, trust has been always an issue, and we always wonder how can we establish trust? How can we create this trust among people who do not need to trust each other? And blockchain technology came as a sort of solution to that. But how does it do it, and what kind of technology it is? Because we keep hearing about it. So I hope today you will have a clear understanding about it. First of all, we start with a fancy Wikipedia definition of blockchain. Blockchain is a growing list of records called blocks, which are linked using cryptography. The first thing I would think of when I see this, I'm like, okay, so what's a block? And what's a blockchain? Like, how do we chain these blocks together? It sounds a bit abstract. First of all, then we'll see what a block is. And so this is a fantastic block. As you can see, it has particular features. First of all, it has a number, which is the block number, which is the hashtag one. Then inside you have data, and which could be everything. It could be a transaction, it could be a document. Well, we will talk about it later on. And there are two weird words that I just throw inside this block, which are hash and previous hash. So don't get scared. I'll explain what they are. Just keep in mind at the moment that a block contains an hash and a hash about the previous block. This is really important because it's with this previous hash, with this hashing mechanism, that we actually link this block together into a blockchain. So that's our blockchain. The first one, as you can see, is called the Genesis block because it's the first block ever created, and it has a particular feature that there's no block before. That's why we call it Genesis block. And how are these blocks linked to each other? If you can see, there are these numbers which are called hash, and each block refers to the hash of the previous block. So inside each block, as you can see, there's a number, the block number, there's some data, there's a hash, which is, we can say like it's a signature, it's a unique identifier of each block, and the previous hash, which is the hash, the identifier of the block before. So all these blocks are linked to each other in this way. So now, after all of this hashing, I would like to introduce to you then what we think are the 5 basics principles of blockchain. And we think that if you know about these 5 points at the end of the session, you know more than 90% of the people who actually invest in crypto, and for sure more than those that invested in December 2017. So we'll start first with hashing, then immutable ledger, decentralization, consensus, and finally what we're waiting for, cryptocurrency. First of all, hashing. So what is an hash? We can say that a hash is what a fingerprint is what a fingerprint is for a human, but in this case for a digital document. So it's a unique identifier. This string, this is a hash, and this uniquely identifies this particular piece of document. And at the same time, this fingerprint would identify one person, so each person has a single fingerprint, and it's unique. What hashing aims at is giving this kind of fingerprint to something that doesn't exist, something that is not tangible, so a digital document in this case. In particular, blockchain uses the SHA-256 algorithm, which is a secure hashing algorithm, and made of 256 bits. And what does it do? This algorithm is like a sort of machine where you throw inside whatever document you want. It could be an audio file, it could be a Word document, it could be a picture, it could be your grocery list, whatever. Then some magic happens, and you get a 64-digit hash, which is composed by numbers and letters. The numbers range from 0 to 9, of course, while letters only from A to F. So in total, there are only 16 values that each value could be. But what's the buzz around this hashing? As you can see, this hashing, it's quite fun because you can really throw in whatever document, the largest or the smallest, and you always get a 64 digits number. I'll show you now how. For instance, if you put the whole Bible book, like the whole Bible, just it took a while, you finally get this 64 digits. So this is a unique identifier of the old text of the Bible. And then, if I just put the sentence "to be or not to be" from Shakespeare, I get still a 64 digits identifier, even though it's of course way shorter than the Bible. And to keep the inspiration level high, if I put beer in it, just the word beer, I still get a 64 digits number. So it doesn't matter how long it is, doesn't matter how large the file is, I always get the 64 digits. And to dig into this algorithm, which is quite a scary word for me, I'll just show you some features that this, let's say, machine has. First of all, it's one way. So it only goes in one direction. If I have a document and I hash it, I get a hash, but I cannot get the document from the hash. Make a comparison, I can get bread from flour, bread from flour, but not flour from bread, because as you can see, it's only one way. So this way makes it impossible to infer what digital documents stand behind a certain hash. But at the same time, you can hash everything. It's deterministic. So what does it mean? It means that if I keep throwing the same word or the same document inside this algorithm, inside this machine, I always get the same hash. As you can see, for instance, if I keep throwing beer, I always get the same. It doesn't matter how many times I do it. And this is important because then it's not at random. It's not completely at random. It's just the code, the hash really looks different from one to the other when I use different words. Last but not least, the avalanche effect. So if I throw inside TGIF and I get this hash. If I make a small change to it and just put some croquette in it, so it happened here, I get a completely different hash. Really, you can see they don't really match at all. And even though I changed just one letter inside it. So this is called the avalanche effect, and it's really nice because then it's impossible. If you get really close to a certain hash that you want to find, you don't get close. It's impossible because if you do a small change, then you get a completely different hash. So this is a characteristic of the SHA-256, really important. So okay, I'm talking about this hash, really nice, but what's the link with blockchain exactly and how does it work? So basically each block that you have in the blockchain is passed through the algorithm, and you get our fantastic 64 digits hash. And this hash then, as we saw before, is included, for instance, the hash of this block, which is 128F, is included inside this block. By this way, we say that these blocks are cryptographically linked, so that the hash of one block, when I hash it, because when I hash the whole block. I hash the data, I hash the hash, I hash the previous hash, and I hash the number. That means that they are kind of linked to each other, because every time I include the block before in my hashing algorithm. So this particular feature of blockchain, so the fact that these blocks are cryptographically linked, gives another characteristic to blockchain, which is really important, which is known as the immutable ledger. So we keep hearing that blockchain is an immutable ledger, means that it's a record, let's say it's a book that cannot be changed. Once something is written on it, for instance, the clay tiles, once you write something on it, you cannot change it. But how exactly? So in a traditional ledger, if I buy a house, let's say I buy a house one day, 2015, I sign my contract, and I leave it in the municipality or in an institution, and they know that this is my house. Perfect. But what happens if one day someone, after a couple of years, gets inside the system, gets inside the government, or the building, I don't know, sets on fire, and I lose my contract? Then nobody knows whether this was my house or not. Or someone can just change the entry or someone can still just manage to change the entry and say like, oh, this is my house. How can I prove that this was my house, actually? This would not happen if this transaction, this contract, was put on a blockchain. Why? If I change anything in this block, which is, for instance, changing the name of the person who the house is assigned to, as you remember before, the hash would completely change, completely burst. This means that this block, which contains the previous hash, so the hash of this block, would change, would fail. And at the same time, since this block is linked to this block failed, this block would fail as well. So a malicious person, someone who would like to actually hack or get into my system, would have to change not only this block, but also this block and this block. And this, of course, is really simplistic, but imagine there are 1,000 blocks. This will take a hell of a time, and it will be almost impossible to do it. But I say almost, and that's not something you would like to hear when you're putting your house into account. And that's true, because actually in this system could still be tempered at a certain extent. Someone could just spend a lot of time, recalculate the hash of this block, then recalculate the hash of this block, recalculate the hash of this block, and then the blockchain would look fine. Every block would refer to the previous block, and it would be fine. So how does blockchain try to solve it? Basically by including the blockchain within a decentralized network. What is decentralization, though, exactly? We can imagine decentralization as, at least in this case, as a network of computers. And each computer, behind each computer, let's say, stands one person or one individual. From now on, I will call these people nodes. So these are called nodes. What happens in blockchain technology is that the blockchain gets copied to all the different nodes in the network. So every node has exactly the same copy of the blockchain. And the system constantly tries to check whether they all equate or whether they are all the same. And this is an important characteristic, because if it happens what I was saying before, so if I try to change, for instance, if one node, this guy tries to change the blockchain, his local blockchain, tries to hack it, the problem would be that this person would be under pressure by the others, because this network would constantly check whether they all are the same, and they will be like, oh my god, this is different than us. This is different than all of us. And so that means there's a problem. What the network does then is tries to understand exactly which version of the truth is the right one. And to do this, usually they work to a consensus, to a majority. So in this case, as you can see, there are 5 computers. 4 nodes have this version of the truth, while this one doesn't. So by brute force, they kill it and they say, no, we hold the truth. The only way for someone then to hack the system would be to actually manage to change the blockchain inside the majority of the nodes in the network. In this case, of course, there are 5, so we just need 3 computers to be hacked to actually make the malicious transaction work. But of course, in reality, there are not 5 computers. There are millions, or even thousands, if not millions, of computers are connected to the blockchain network. So that would mean a person would have to hack at the same time hundreds of thousands of computers, and just for a damn house, it wouldn't make sense. And it would be impossible, because the size of the hacking would be way too large, and nobody ever managed to hack a blockchain. For instance, Bitcoin has never been hacked. If it gets hacked, it's your fault, not the system fault. But okay, so we have these people who don't know each other and are all over the world. These nodes, it could be me, it could be someone in Australia. And how do they communicate? How do they know whether this block was actually bad or whether that block was fine? The only way to do this is to set a consensus protocol, a consensus method, a method to reach, to know whether something is fine or not. It's a kind of set of rules that the network sets. In this case, let's say you want to add a new block. How do we determine whether this new block is fine, it complies to the rules or not? Or if someone tries to tamper the network, how do we know whether this is actually wrong or not? How do they communicate? That's why they developed consensus protocols. protocols. And at the moment there are several, but today I would like to focus on one, which is the most famous one, and it's the one by Bitcoin, which is called proof of work. And proof of work is a way to reach consensus within a decentralized network. But what is proof of work? I'll start with an analogy, which I hope will make it clear for you. It's a kind of lottery, but a weird one. It's a reverse lottery. So you already know the winning ticket. You know the number, you know everything. You know, like this is the ticket that you need to get to win. Like, you already know the number, and so you could just, okay, I just buy the ticket with that number and win. No, it's not that easy, because what you have to do is keep buying and buying tickets, because you can only buy tickets at random. So every time you buy a ticket, you get a random number. So you have to keep buying until you finally someone finds the right ticket and wins the competition, and wins the lottery, and wins, of course, its prize. So as you can see, you know the price, you know you know the score, you know what you have to achieve, but it's impossible for you. It's not up to you to achieve it. You have to run several times. You have to buy several times tickets, just hoping that you will get the right one. And that implies a lot of work. And as a reward, of course, in this case, you would get a prize or some money. Proof of work is as such. So we have a goal, this orange block. We have to create this orange block. Everyone knows, okay, it's an orange block. But how do I get this orange block? Nobody knows. But so in order to get that block, they need to, all the nodes, all the computers, need to start some computation, need to actually start guessing at random how to make this orange block, until finally someone finds it. This person then is awarded with a prize, which usually, let's say, what is the most common one is Bitcoin. So in this case, you would get a Bitcoin. This person then would actually add a block to the network, and all the other nodes would, of course, check with a consensus protocol whether this block is fine, and then this block would be copied all over the network. And then the competition would start again to add a new block to the chain. So you may wonder, how can this, like, why do these people then just try to maintain this network? Why do these people put this effort in checking the network constantly and trying to find a way to make sure that the system, the integrity of the system is preserved? As I showed you, in this case, someone would get a Bitcoin. But what is Bitcoin? Bitcoin is, of course, the most famous cryptocurrency we ever heard of. And the cryptocurrency is basically, it's a decentralized currency, which is managed by a blockchain, and is used by the blockchain as a way to keep the system preserved, to keep the system integer, because it rewards those who actually try to make sure that the consensus protocols are followed. So there are several, and for instance, Bitcoin is one of them, and there are several others. But the goal of these coins, of these cryptocurrencies, is to give an incentive to someone to keep actively checking and actively making sure that the network is safe or the network complies to the rules. So that's why we have these cryptocurrencies, not just for trading. There are several characteristics of cryptocurrency. I'll just shout the first three we could think of. It doesn't have an intrinsic, or we would say it only has a perceived value. I mean, with a Bitcoin, it's not worth anything. It's just a piece of code. You cannot really. It's not like an animal that you could eat or something. So people believe it has value, and that's why it's worth it. That's it. It doesn't have a physical form, as I said. It only exists in the network. And the supply of it, it's not determined by a central bank, but it's determined by the network. By this way, nobody can actually manipulate the release of new Bitcoins or new cryptocurrencies. And it's all written in a code that nobody can touch. What can you use a cryptocurrency for? You could use it for trading, but watch out, it's really risky and people lose a lot of money. You can make payments with it. For instance, Bitcoin was the most famous example. You can access the platforms. So some platforms, for instance, create a currency, and you can only access the certain services within the platform with that currency. So then if that platform does a really nice service, this currency becomes really valuable because many people will want to access to it. And is a store of value, but not a really good one because as we know, the price can changes over hours or even minutes. So it's not really. If you get your salary don't ask to get your salary in bitcoins because maybe at the end of the month you have half of it, or it could also be double, but half of it works. And especially recently. So these are the 4 possible usage cases of a cryptocurrency. So let's come back to what Bas was talking about. This blockchain technology, as you can see, it rests on a system of guidelines. So which are the rules, which is the network, for instance, or how the network is structured, what consensus protocols are in. All of these rules are the sort of guidelines that we set. It's public, everyone can see it, everyone can check the blockchain because it's decentralized, everyone has his own copy, and it's the same for everyone. It's not hidden in a bank or in an institution. And it's append only, which means it's immutable due to the hashing link between blocks. So it's a new way to do something which we've been trying to do for all of the history. Finally, we have some thoughts on because we have been working with blockchain within the company. We interview some people also because we're trying to see what we can do with this technology. And I don't see many people that I interview, so I guess they were a bit sick of our pushing. But so we kind of master a bit the concept, and we have some thoughts about this technology, about its opportunities and challenges. The challenges is, first of all, there's a lack of real use case, and we're actually encountering this issue as well because it's hard to make something that as value because it's on a blockchain. Many people just build something on a blockchain to follow the hype or the vibe that it's now, but perhaps you could do it in a way easier way and without saying blockchain. So it's hard now to find really a good real use case. Bitcoin is probably so far the best and the most adopted one. It's complex to grasp for end users, so that for some people, sometimes you have to hide the fact that it's built on a blockchain, because for some people it's a scam. People who do not know much about this technology still they don't really like hearing about it because they associate with Bitcoin and other like bad crashes. There's a lack of regulation and a risk environment. There are many scams. Like we also found some pretty fun ones. And with people just saying this is a new product developed on blockchain and blah blah blah, and the price, and then they just try to go to the stock market and people buy it, and then they lose all the money because it was built on nothing. And the technology is still not mature. The guys that are coding in our team are really experiencing this. It's really hard. There's so many lack of documentation or inconsistencies that make it hard now to really do something with blockchain. Opportunities, we are cutting out the middleman because this is a system which is, as you can see, you can establish trust between people that don't know each other without any institution, without anyone in the middle that can make sure that trust is in place. It's transparent because it's public, everyone can see it, everyone can get his own copy of the blockchain. It's safe, and as I showed before, it's really hard to tamper due to also its immutability. So these are characteristics that are really valuable, and something very nice could get out of this. Of course, we're still wondering what, but we're working on it. Yeah, that was it, I think. Yes, thank you. Okay, first of all, I'll just leave this in the background so then you can write in your agendas. These are the next meetups. Next one will be on use cases in digital marketing, which we think will be interesting, especially now that you gather some knowledge on the technology in general. Then the technology in depth, which will be a bit nerdier than this. We were almost risking to make this already a bit nerdier, but it will be way more on the technicalities behind it and how hashing works exactly and how these algorithms look like. So this is quite actually exciting. Smart contracts and dApps. So with our smart contracts, which we keep hearing a lot about, and you can see that they're not really smart, but we'll show you how they can be smart. And finally, hopefully, by the 23rd, we have a nice live project to show to all of you, and that will benefit the company
before you guys leave, because this feels kind of like the ending slide, I want to ask you guys if you have any questions on the content, if you have any questions that's still not clear, if you have any questions, okay, how this is work, this is like the moment to ask us and the group. So I wonder if anyone had any questions that weren't clear? Or
So you have a lot of scammers, but how do you find it? Because if you have the blockchain, is that enough, or why do some cryptocurrencies, for instance, fail, and why some scammers, and why do some stay strong?
I mean, I guess behind like scammers, for instance, if someone makes a token and then it makes a coin, a cryptocurrency, and then goes online and says, okay, this currency is gonna do all of these fantastic things, and you do not know much about the technology, but you just read that they're promising a lot of interesting things. It's up to you, of course, to read through their documentation, read through their white paper, which is basically their story, what they want, what they're telling you, their business idea, and before actually you would start investing in it, because they need to. I think the main concept is they need to solve a problem, and if you read by reading this, you're not convinced that they're actually doing it, then it might be just a hype or something that's not going to last long. Yeah, that's much. Yes.
Okay, so if you have bitcoins and you trade bitcoins, how does that work?
That's the next session.
Okay.
Oh yeah, I'm
So
sorry, I forgot to say.
good promotion for the next session.
More details on cryptocurrencies and actually how they are, how they're handled, where do you store them, how do you trade them. This will be done in the next technology in-depth session, because we believe that cryptocurrency is just part of a big picture. It's the technology today. We want really to give you an idea of the technology before you could understand what cryptos are and what they are for. Yes.
I have a more basic question. Well, just to understand the basics, what if I want to change the contract that's at the...
Sorry?
What if I want to change the contract of my house?
Then
Then will it be a new block, and saying the old block is not the right one anymore?
Yeah, I think what you would do is just making a new, like putting a new contract on the blockchain, and then should there be a problem, you can, this blockchain is immutable, so you can see, of course, in history that the last contract is the one that counts, of course. But the fact here, it's more the fact that this change will always be there. Like you will always have these two contracts, and you can always show this to someone that this is not gonna be tampered. That's really important. So if you just change it by deleting and then you put something more in it, which is what you would do like today, if you have like a list, okay, you want to change your contract, let me change it. This would not be tracked, this would not be public. Like this would not be, you could not say, oh no, I didn't change it, or I did. Well here, it would, because there will be a new updated version of the contract, and we think this is a contract that has not been, this is a contract that has not been tampered in any way. Otherwise the whole chain would fall down.
Okay. So when I want to see my contract, for example, the blockchain knows that there's a new
No,
version.
not the blockchain is not that smart. But I mean, I don't know, why would you need to see your updated contract? Because you have, I don't know, let's say you make a contract and you ask for us, make a contract at Greenhouse, and you have a contract, you earn a salary, and then you make a new contract where you earn a higher salary.
Yeah.
So it's the same contract but higher salary. The thing is, if after a month you check your bank account and you find the same salary as before, then you can go to someone from Greenhouse or HR and say like, hey, we agree that I would change my salary, I would upgrade it. And then this is written in stone, so to speak, because you would open the blockchain, you know where your contract is, and then you say, yeah, this is my contract, not like that. This is my salary, not the one you gave me. So this is really important. It's a ledger. It's a book that you can open and find what you need. But it's not smart. It doesn't do anything by itself.
But it goes also a little bit further, though. Like you can also agree in the blockchain that for the contract, some company may do automatically a higher
Yes.
salary.
That's a smart contract. I think that's smart
Smart
contract.
contracts,
Which, this of course, but this is still something inside a block in a blockchain. So it's not like the blockchain
No.
itself. So, but yeah, also smart contracts. Session number 2, I think. No, 4.
4.
This will be really interesting. Yes.
You said that every block contains a hash and the previous hash. But in the example, it only had 4 digits, but does it mean that every chain has 128 digits characters?
It has, no, this was for sake of simplicity here because I had to put 64 digits.
Yeah, okay.
But yeah, this is 64 and this is 64.
So that's 128 for every.
Yes. But yeah, of course, this one you get it once you put everything else in the hashing algorithm. Like this gets stamped on top, and that's your identifier. Another question? Yes.
The computers that are checking the blockchain
Yes.
and also the computers that are adding a block, those are all miners, right?
Yeah, they define them as miners. Those people. Yes. Yeah, mining is basically the competition that the nodes do in order to add a block. This is called mining. Why it's called mining, I think this is a bit too technical, so we can dig into it. We can mine into it.
Session 3 is going to include
So
mine.
many sessions.
Not all computers have to be in Minecraft, right?
No, they don't have to.
be just fair.
No, but some people, they want to, I mean, if you put your contract on the blockchain and you just, okay, because I believe blockchain is safe and I want to make sure it stays there forever, you can just put it on and not looking at it anymore and it's fine. Miners are people who actively want to earn something out of this. Like some people made a living, made millions out of it, and they just keep putting new blocks in the blockchain. Even with transactions which are not from them, they just find transactions on the internet and online and they put them together in a block and keep adding it. Yes.
But then if I were to put my contract, for example, on the blockchain, a new block would arise, would that also mean that all the miners have a go again at mining that block?
I mean, if you put something from you,
Yeah.
what you mean like you also try to mine?
No, I just put something in there, but would that mean for everyone else who is mining that they have a new block ready to mine?
They have a new transaction, a new piece of data that can be put in a block. But yeah, also this process, like the selecting of the transactions and putting them inside the block, it's quite a technical approach that we will address in session 3.
When does a computer become a node in a network?
I think once, don't know technically how, but I guess when you basically just, how does it work? You know? You just
you'd have to
the
download some
piece of
software from that blockchain and
And
start
you are
mining
not-
to have a copy of it. And anyone can do it.
Yeah, you
You don't
just
need
put
to have a request or invite or something like that. That was your point.
And why would you do that? What is it?
Because you want to mine.
Sorry?
Why should I download that software and make my personal computer or laptop part of the node network?
Because you may want to include a transaction, you may want to include some data, some data that
part of
you,
the network first before you can act.
yes, that's the basic of it.
Okay.
And then you keep getting a copy of the blockchain.
There's 2 main reasons, actually. You may want to contribute to the security of the system and implicitly your data that you want to put on the blockchain. And the second one, you might want to participate and maybe get the reward or part of a reward.
That has then to do with the trying to get the winning lottery.
Yes.
Yes, the
Yes.
inverse lottery.
The inverse
It's kinda
lottery.
you're then a participant, so to say.
Let's say there are some nodes which are more chill nodes and some are hardcore. And the hardcore guys, they want to make money out of this, when other people are just want to keep their information stored. And these people then get to the next level and start playing this lottery. But you don't have to play this lottery, this is just a way. And of course, nobody would do this lottery if there was no prize attached to it. And And that's why we have cryptocurrencies, because cryptocurrency is the price you get if you want to participate in this lottery, and this makes the whole system work.
So it's basically like a side project of the blockchain.
It's the incentive. You make this to make sure that people have an incentive to check on other transactions. Like, why would they check your transactions or someone else's transactions, and why would they create blocks if they don't get any benefit out of it? That's how I do. Because if I win this lottery, then I get money. Yes.
Could be like some mismatch between the amount of blocks being available and like the data being want to be stored in the blocks. Like if you want to store some data in the blockchain, like there aren't enough blocks available, or the other way around, that people are buying, so there are like empty blocks being created, and there's the data to be stored in that, or is not the correct way to do it? Or like just there, when data is offered to be stored in the blockchain, then the process of finding begins.
I think the problem usually is actually now that there are many transactions, and there's the process of building blocks is still a bit slow. So it's one of the limitations of blockchain. So usually it's that's the problem, because building these blocks takes time. As you can see, this lottery takes an average 10 minutes. That's what they say. And so this sometimes it could be that there are so many transactions that this transaction is not processed in due time and just after a while. So that's why right now you cannot maybe go and buy bread with Bitcoin, because you send a payment, but first has to be mined, has to be processed. So this may take 10 minutes, or it may take an hour. So maybe this person doesn't have this money. So that's the problem. Yes.
There are now maybe like 1,000 cryptocurrencies. Do they all have their own blockchain? Do they rely on Ethereum and Bitcoin?
No, okay. So I'll try to make an explanation, because first of all, blockchain is a technology, right? So blockchain is a technology. On this technology, we built several. They're called protocols. The most famous one is Bitcoin. Then there's Ethereum. Then there's Ripple. It's just different rules of the game, basically. Everyone built his own blockchain with his own rules. Out of these protocols, coins are created. Then tokens are created. So all of these millions of tokens could be created from a protocol, existing protocol, or you might create your own protocol and start making tokens out of it. But yeah, like this detail on cryptocurrency is also more. We'll also dig into it. Session 3.
No more questions? Well, thank you very much then for being here.
Thank you.
Just last question from my point of view. Was it a bit clear, or was it already too in-depth? Clear? Okay. Good to know. Thanks.
I think people didn't understand it.